Question 42. An archer shoots an arrow from a height of 1.14 meter above the ground with an initial velocity of 47.5 meter per second and an initial angle of 35.2 above the horizontal. At what time after the release of the arrow from the bow will the arrow be flying exactly horizontal? So let us first sketch the problem. You have an archer that shoots the arrow from a height of 1.14 meter from the ground. So this distance of the arrow from the ground is 1.14 meter. And initial velocity of the arrow is 47.5 meter per second. So let us write down these velocity values. V0 equals 47.5 meter per second. And this velocity makes an angle theta of 35.2 with the horizontal. So we can draw the velocity component. This is the velocity of the arrow making an angle theta. Then the arrow will follow a parabolic path and fall back on the ground. We need to find at what time will the arrow be flying exactly horizontal. Now in an angle launched projectile, the initial velocity has two components. One that goes along the x-axis, which we write as Vx0, and one that goes along the y-axis, which is Vy0. Now for the arrow to remain exactly horizontal, the only component of velocity it must have is the x component of velocity. The y component for this particular moment has to be 0, because only in the absence of y velocity can the arrow be perfectly horizontal. This is possible only at the highest point, because at the highest point, the y component of velocity becomes equal to 0 and the projectile velocity is purely horizontal. So I need to find at what time t does my arrow reaches the highest point. We can use the equation of velocity to find the time t. We know y component of velocity at the highest point will be 0. We know the initial component of y velocity, Vy initial will be equal to V0 sine theta. Using these two velocity values, we will calculate the time t. So let's use the equation for velocity. V final equals V initial plus A into t. I need to find the time t, so we will rearrange the term. I will move V initial to the other side, so we get Vy minus Vy0 equals A into t. Divide by the acceleration, so you get the time t to be equal to Vy minus Vy0 over A, which we get as Vy minus Vy initial is V0 sine theta, divide by A. Now substitute the values. Vy at the highest point is 0 minus V initial is 47.5 sine of the angle theta, which is 35.2. Acceleration A is acceleration due to gravity, which is negative 9.81. And when you solve this, you get the time at which the arrow is perfectly horizontal to be equal to 2.79 seconds.